Let's take a look at probabilities of draws with replacement. In this first example, it says a fair die, dice are rolled 6 times. What is the probability of having no 4 and no 6 among the rolls? Round your answer to 3 decimal places. So what we want to have happen is on 6 different occasions, we want to roll no 4 and no 6. So remember, these are independent events. Every time I roll the die, like that first roll compared to the second and compared to the third and fourth, fifth, and sixth, the probabilities that I get no 4 and no 6 is the same for each roll. It's not like if I got a 4 in the first roll, I'm less likely to get the second roll. All these rolls are independent, and they all have the same probabilities for each roll. And so, for rolling 6 times, I want to see what's the probability that I will not roll a 4 and a 6. So let's find out just what the probability would be if on just any one roll that I get no 4 or 6. Well, you know that there are 6 total outcomes, right, for the roll. It could be a 1, a 2, a 3, a 4, a 5, or 6. And if I want to have no 4 and no 6, if I take the 4 and the 6 away from the possible outcomes, that means I only have 4 possible ways I can get what I want, right? So that would be like rolling a 1, a 2, a 3, no 4, and no 6 would mean the only outcomes that I want would be getting a 1, a 2, a 3, and a 5. There's 4 ways that can happen out of the grand total of 6, right? So this is the way you set a probability. The number of ways you get what you want, which is 4 in this case, out of the grand total ways it can happen, 6. So that's the probability to do that on the first roll. It's exactly the same if I rolled it again and again and again and again 6 times. The probability that I get no 4 or no 6 is always going to be 4 out of 6. Now, if I have to do that 6 times, since it's got to be this and this and this and this and this, I just got to multiply this all together. So the faster way of doing that would just be 4/6 to the 6th power, or 2/3 to the 6th power. So if I use my calculator and round to 3 decimal places, we should have this licked. So 2/3 to the 6th, and change that to a decimal. So to the nearest 3 decimal places, that'd be 0.087, but that 7 is going to round that puppy to an 8, so 0.088. Oops, 0.088 would be my probability for that one. Let's look at one more. So an urn contains 7 red and 8 green balls. 4 balls are randomly drawn from the urn in succession with replacement. So every time you draw a ball, you look at it and put them all back into like the urn or the box, all right, where they're all laying in there. Now, that is after each draw, it's returned to the urn. So what is the probability that all 4 balls are drawn from the urn are green, round to 3 decimal places? Okay, so again, this is similar to the last one because every time we draw a ball, there's going to be a grand total of 15 possible outcomes when we draw. And so here we want to try to figure out the probability that all 4 balls drawn from the urn are green. So the probability that it's green, there's 8. Every single time there's 8 green, which is what I want, out of a grand total of 15, right? So that doesn't change. Every time I draw, I look at it, I put it back in, and there's 8 green and 7 red to start with. But now I got to do this 4 times, so it's just simply that ratio to the 4th. So I'm going to do the calculator action, 8 over 15 to the 4th, since we're doing this 4 independent different times, and I get 0.081 that 9 rounds the 0 to a 1. So 0.081 would be the probability here. Hope this helps. Thanks for watching.